Good afternoon, everyone. My name's Daniel Leivers. I'm going to talk to you about GraphQL for a period of time. I'm a freelance iOS developer, and you can find me on Twitter and the web there. Before we dive into everything, tiny bit about me. So about 10 years ago, I got engaged, and the iPhone came out about the same time. So I borrowed a load of money from a honeymoon fund to buy a MacBook to write some iPhone apps. Luckily managed to make enough money back to repay it and still get married. Since then, I've been developing on iOS and a little bit on Android ever since. I've been very lucky to work on a number of really impressive brands, and I now help run a meetup group in Bristol called SW Mobile. We're always looking for speakers or people to just come along. So if you're interested in that kind of thing, and if you ever find yourself in that country and part of the world, please drop in and say hi. So this talk, I should sort of prefix this with I'm not by any means a GraphQL expert. I've been using it for about a year on a project for a client, and this is sort of a summary of my experience and what I've taken away from it and some of the problems I might have hit. So I'm going to talk a bit about what GraphQL is, where it's come from, why it's a thing, show some examples of how you use it, and then sort of walk you through some of the pitfalls that we faced so that hopefully you don't hit those same things. So firstly, what is it? So it's developed at Facebook and then open sourced about 2015. It's sort of an alternative to REST-based APIs. It's a specification, so there's many implementations across different languages, so it's not tied to any particular thing. And much like SQL or something like that, it's a query language where the client specifies what it wants. And then why did they do this? So there are several goals behind this. One of them is type safety. With a lot of things, you get back just munches of strings, and you have to sort of try and decode it and hope that it is what you think it is, and then extract that. And if you've done it all right, nothing crashes, and you've got what you wanted. And if you do it wrong, you've got crashes and all sorts of nastiness. It's partly to reduce the need for back-end development. So by pushing the queries as a client responsibility, it's not an onus on the back-end developers to be updating those queries anymore, to be changing what you're giving back to the clients. And then it's to reduce data as well. Because as a client, you're responsible for saying what you want and what you want to push back. There's not necessarily any wasted data of things that you just didn't need from the server, but the endpoint happens to give you that anyway. So this is all going to go slightly Star Wars-y because, well, for several reasons. One of them is the official I nearly said the official Star Wars documentation. The official GraphQL documentation tends to reference Star Wars quite a lot. So lots of the documentation and examples you'll see on the web is sort of Star Wars related. As well as this, there's something called swappy.co, which is a Star Wars API, which is available in REST. And then there's a GraphQL version of this as well, so we can sort of directly compare two examples of doing the same thing in different ways. So the thing we're going to build as an example is Star Wars IMDB. Very simple app, nothing like IMDB, but it lists the films and doesn't quite have the latest one in there. So all we're looking for the initial version is just get titles in, throw them up in a table view, nothing complicated. So if we're doing this with REST, the swappy.co API provides these endpoints. We're obviously interested in the filmed one, because that's likely to have the film names in. So if we call that endpoint, we get this gigantic blob of JSON back. And out of all this, we're going to decode it all, run through various parts just to pull out the film names. And that weighs in at 18.82 kilobytes. So it's quite hefty. If we're going to do this with GraphQL, we've got one endpoint now. And we write a query that we send to that endpoint just requesting the title of the films. Then when we run that, we get back this blob of JSON, which is a little bit smaller, just listing the films, because that's all we ask for on the client. And that comes in at 0.22 kilobytes. So there's a huge data saving there. And this it's quite a contrived example, obviously. But can you really say that your REST endpoints have been sort of tidied up nicely so that all the bits you don't need are removed? I've got one of the clients I work with has a profile endpoint where it gives back a huge amount of information because it's also used for the website. And all we actually need from that is the image URL and the name, and it's something similar to the previous example. So it's not too contrived an example. So what happened there? We've got one single endpoint for GraphQL. We construct a query, we send it across. The server gives us back just what we asked for, nothing extra. So then how do we do this on iOS? So on iOS, there's a lovely CocoaPod open source library called Apollo, which just handles a lot of this complexity for us, puts a workflow in place so that you can just get this all up and running quite quickly. So the first thing you need to do is get the schema. And when you're reading through all the documentation on graphql.org or one of the other resources, they talk a lot about schemas. And there's actually several at play. And when I first came to this and was sort of skim reading it, as you do, not necessarily taking in every detail, because it's a lot of that documentation is aimed at back-end developers and people creating this stuff at that end. I hadn't quite realized that, so I was looking through, and there's this lovely schema, and it's human readable, you can pick out exactly what you need from it. That's not the one you want. It turns out there's a less readable schema, which is for the client, for mobile apps or whatever it is, called the introspection schema. And Apollo provides a tool to extract that from your server. So with your sort of CocoaPod installation of Apollo, you can run this nice command on the terminal, and that will pull down the schema from your backend. You then take that schema, you drop it into Xcode. You also have to provide some queries with it, so you have to have some idea of what you want to do up front. And then with those two combined, you can build, and out will pop an API.Swift, which is all of this stuff to use your query you wrote, all compiled in nice type safety. So then to actually use this query, we have this fairly small bit of code. We've essentially got a variable that is typed to a horrible nested list of objects to hold an array of the results. And then we call Apollo with fetch, and a sort of query name with the word query appended on the back of it, and then the results come back in the closure. So that gives us our sort of initial version of the Star Wars IMDB app. So if we want to extend this a little bit further, and we want something a bit more complicated happening in our app, so we're going to introduce a new screen. So when you tap one of those titles from that initial listing, you can go in, you can see the title of the film again, the first 3 lines of the opening crawl at the start of a Star Wars movie, and then a list of some of the characters from the movie and their home planets. So we need to write a new query. So to do this, the GraphQL implementations you'll find, if you point a browser at the base URL with GraphQL on the end, so the sort of the GraphQL endpoint we were looking at earlier, you'll get this UI appear in the browser. And this lets us just tinker about, run queries, run mutations, assuming the server's not sort of locked down. But also on the right-hand side, it provides the documentation based off that schema. So you can browse through what's available, what queries exist, what mutations exist, what variables it takes, what it returns, what the types are. It's very nice. So this is going to be a really sped up video of creating a new query. If you blink and miss it, we're going to deconstruct it after, so we can sort of dive in a bit. So essentially, we can browse through the root of it. We can look through what's available on the right. On the left, we're starting to build up a query. So we give it a name, give it a parameter we're going to pass in. It's going to call the film query. And then it'll auto-complete what results you want to see back. Sort of go down, look through relationships to characters, explore the type of that character and what parameters come back on that object. And it very quickly builds stuff up. If you run it without passing a parameter, it fails. So at the bottom left, you can add in parameters you're going to pass in, and then you get back your completed result in the middle. So it's very useful for quickly iterating over, prototyping it, playing with it, seeing what you can take away and add in. Apologies for the slightly squashed 4x3 screen on this one. So that comes out with this query. And I've just noticed the next slide's going to do this as well. So what this consists of is, this is pointing at the wrong thing, I think. So the query name is actually the line above that. So the film detail is what we've called our query. We've got our parameters that we're going to pass in, which is the film ID. The $film ID is something we define ourselves. You can call it whatever you like. You can call film detail whatever you like. But the film on the next line before the parentheses, that is the actual server query name. So the parameter type, which is actually ID exclamation mark, is very Swift-like in that if it's got an exclamation mark, it's a non-optional, so you have to provide that for this query to run. If you don't provide that, the query can't do anything because it doesn't know what film you're talking about. The server parameter name is actually meant to be the film ID after the server query. So where query name is pointing to at the moment, that film ID is the server version of that name. So that has to match what's on the server as well. I'm just going to skip that one. And then these are the results we're expecting back. The sort of title, opening crawl, the character connection relationship, the characters within that, the name of each character. They've got a relationship to a homeworld, and each homeworld has a name. So we're sort of pulling back that complicated model, if you like. So each of these things, which are going to point to the wrong thing again, all come from parts of that documentation that were on the right-hand side in the GraphQL browser. So all of it's there, and the naming of it is sort of on the responsibility of the back-end developer or the server developer to both name it sensibly, give it a sensible type, and put this nice description that you're seeing in. So it doesn't eliminate all effort. See, they're all there. And then you've got this homeworld planet relationship, which you can drill into, and that gives you the homeworld name. At least those point at the right bits. So this query in action is very similar to that previous one we saw, where we're essentially saying, we want to use the query we compiled called film detail query. We're going to pass it into Apollo. We're going to give it a film ID to tell it which film we're looking for. And then we're going to get back this lump of results. These are optional strings. This is an optional array of characters. There's a question mark slightly off the screen. And then that gives us the screen we're after. So if we were going to do this the other way, if we were going to use REST for this, we've got our client on the left, we've got our server on the right. First thing we're going to have to do is we're going to call the films endpoint with a parameter to say we want Return of the Jedi. So we call it with ID 3 to get the third film, and that gives us back a blob of JSON. Now the REST version of this data isn't structured in such a way that that will give us the characters. It will give us the IDs of the characters in that film. So we're now going to have to call the people endpoint with the ID for each of the characters from the previous. So that's 20 calls. And that gives us a homeworld ID in each of those for the homeworld of each of those characters. So we're going to have to call the planet endpoint with the ID of each of those characters 20 times, which is quite a lot. And again, this is a very contrived example, but these things do happen sometimes in the real world. So this sort of can try and eliminate that off the bat, potentially. So the next step from this is we're working on this app. We maybe get a new product manager. They're maybe not a fan of the prequels. They maybe want to be able to delete some movies. So we want to be able to mutate the data. So to mutate the data, we can do mutations, which are very similar to queries. You're just prefixing things with a mutation keyword, giving it the ID of the film you want to get rid of, and the server provides a method to actually just wipe that film out of there. And that returns us to a nice 3-film listing app. I've sort of cheated slightly, and this doesn't actually exist in the GraphQL server that I'm going to link to later. This is more a teaching element, if you like. So if we're handling errors, GraphQL doesn't like to deal with multiple status codes. The idea is it's just going to return you a 200. You're going to get a success with every query or mutation you pass in. But within that will be an empty result set, if it's something it's not happy with, and or some errors. So you could have something that succeeded and gave you a result set, but you get some errors back as well, for instance. So you can't necessarily rely that that means failure. But you could get empty results, failure reason. So for instance, if we try and fetch episode 8, that doesn't actually exist in this data set. So we get back essentially an empty film object and an error array. So what we've covered so far is sort of how to build a basic app with GraphQL, how to set up Apollo to do it, how to use GraphIQL, the tool it provides you on the back end to build up new queries, and then how to run those queries and how to make mutations. So the next thing is to sort of run into a bit of a case study of my experience with using this on an actual app. I can't go into too much detail on what the app is because it's still not launched. But our general setup is something like this. Our server, represented by R2D2, is running Django with Graphene on there to provide the GraphQL side of things. And then on the client, we've got Apollo. And we're both pulling down content, sort of news articles and things like that, and saving user notes up to the server as well. So there's both queries and mutations going on. So the first pitfall you're going to face, almost guarantee this will happen at some point, is the back-end developer has made some changes to the data model, to how things work, or they've added a new feature in. You try to build it in your app, and it immediately does not work at all. You're just getting exactly what you got back before. And you've got to remember to update that schema. So that magic command that Apollo provides in the tools, you've just got to remember to run that to get a new version of the schema every time the backend changes, and then re-include it in Xcode. Otherwise, your client won't know about any of that new stuff. Equally, you're going to have to provide those new updated queries, if you've got any of those, into the .graphql files. And then compile it, and away you go. The next one is IDs. And this was a bit of an ongoing challenge. So our query from earlier to fetch the detail of one of the films, we pass in an ID parameter, which is fine. That's surely when we do the all films, we get an ID, we put it in there, it's fine. It's not fine. That's not the right ID. It's just not the one. As it turns out, and this isn't exclusive to Graphene, some of the others do it as well, but I'm not sure if it's equivalent across all implementations. We've got this film ID that was initially a string in an earlier version of Graphene we were using. We got back this string as an ID. That may look slightly fishy from the off. It turns out that is a base 64 encoded string, which is the type of the object with the ID, and this is used internally to be globally unique. It's not that useful to us without decoding it. So you end up having to decode it and then split it by colon to get the ID you actually need to use in the queries out. We then got an update from the backend developer, which was great. We now got this ID type back. Unfortunately, same string, same thing. And then not too long after that, they started providing an explicit parameter, an explicit sort of extra field for this. So you could still request the previous one from the server as well, but if we update the queries to fetch film UUID instead of film ID, it pulls back the correct thing without any messing around. The problem is we were then in a state where both of these exist throughout our schema. And if you're using the wrong one by accident somewhere and trying to base 64 decode it and separate it by colon, there's various hazards and things that could trip you up there. So just be careful with IDs. The next thing we faced was subscriptions. Now this is a great idea. So you provide one of those queries we made earlier, like the film details or the listing of films. It opens a WebSocket to the server, and whenever that changes, you get updates. And particularly for our client-side implementation, we were expecting some of these news articles and things like that to change fairly frequently. So being able to be pushed and update to this without us having to explicitly, I don't know, on a timer or something, go and refetch or refetch every time you go to the screen or something like that, it just makes things a lot nicer. Not supported in our version of Graphene, at least. I've spoken to a few people who've had this same experience with things where they said it was meant to be supported, but it just didn't work. So I don't know where the problem lies there. So the next one, which is almost related to the previous one, is the caching. Apollo has got some quite clever caching. So this is a blob of text from the Apollo GitHub page. I'm not going to read it out, but it basically says they try to maintain the state of the backend by looking at the mutations and queries you're making and then keeping the cache in check with all that, which is great. But we're expecting some of our data in our explicit use cases to change fairly frequently and not necessarily by the user. So they could be changing on the server. So we were calling this to fetch our all films query. And we knew the data had changed on the server, but we weren't getting the latest data. So we dug a bit deeper. This is the declaration in Apollo for the fetch function. And you can see in red there's a default value for the cache policy, which is return cache data else fetch. So if it's already built up this cache, you'll tend to just get the cache back. So for some queries where you know you need it more often than the cache is going to retry, you just need to add in an extra parameter to just force it into getting the latest. So the next thing we sort of faced was our client suddenly decided it should be offline first, which was a bit of a problem. Apollo doesn't have anything explicitly built in for offline support beyond the cache. I believe there's some experimental stuff with SQLite in there, but when we started this a fair while ago now, there was just not really anything there for us to use. So we ended up essentially building in a realm database. And it introduces a lot of complexity, as we essentially ended up having to have a second set of model objects, the sort of locally persisted ones, and then we've got our Apollo auto-generated ones, and having to just, I mean, if you're going to do offline, it's probably not a good idea to do it this way. Amazon actually provides some tooling with their AWS setup where they have a GraphQL, I'm trying to remember the name of it, but there's a GraphQL tool they provide where the client library will actually do all of this for you. It'll store it all. You can do all the offline stuff. But we weren't in a position to change servers and use that service. So I wouldn't recommend doing this. Some sort of general other pitfalls we faced are we've still yet to fully figure out what the best way to manage different environments is. So we've got essentially a dev environment, a staging environment, and a production environment. And obviously the production one is almost always the furthest behind. It's the thing we sort of tested in dev and staging weeks, months ago. And you're inevitably going to end up with these different versions of the schema. But they generally recommend against versioning the schemas. You're meant to essentially keep them backwards compatible. So we're managing these different environments by branching our code base on the client side, because as soon as you include the new schema, it gets compiled in. So you can't split it out with targets or schemes within Xcode because it's going to be a compiled file that's in there and potentially checked into version control. So that is its own separate little pain, potentially. Another thing we've been experimenting with, in order to separate some of the GraphQL stuff out, and because we use this server infrastructure for a few other apps that use the same queries and mutations, we've pulled this out into a CocoaPod. And that works quite well. But that issue earlier where you have had your backend developer do some changes and you've now got a new schema, you can drop that in the CocoaPod, that's fine. But if you forget to compile it and check in the compiled version of the API.Swift, none of those changes are going to flow through to the rest of the apps anyway. So there's an extra sort of hazard that needs checking there. and just a general one of, it's only as flexible as your schema. You can write bad things in anything. You can write a bad REST endpoint. You can quite easily write a bad GraphQL schema to fetch your data and mutate your data. It's just another tool. I've sort of realized I've whipped through this fairly quickly, but we've covered what GraphQL is, where it came from slightly, how you might use it within iOS using Apollo to do it, some of the pitfalls that we sort of hit as we went through it. And then that sort of leads us into the main question, I guess, which is, should you be using GraphQL? And there are a lot of plus points, definitely. So, I mean, the type safety is brilliant. When we want an int, it's an int, and we don't need to mess around with that. It's great. The self-documenting nature, using that GraphQL tool to build up queries and mutations is really useful. It's really powerful. When we started this project, we essentially had 1.5 developers. The back-end developer was part-time. And we were able to move very quickly without that extra back-end developer time because we could just build up these queries and mutations without much extra effort from them. The reduced data is potentially huge. I mean, especially in developing markets where data is quite possibly a problem. If you can go from fetching a large blob of data to fetching only what you need, and that's potentially tiny depending what screen you're looking at or whatever it is you're doing, that's just a massive advantage. But the implementations are still a little bit in flux. I mean, it's outside of the pitfalls I mentioned, as has been fairly stable. So it depends where you are in your project. I wouldn't rush out and convert my REST projects to GraphQL necessarily, but if I've got a new project I'm starting, it'd certainly be something I'd consider. And then some further reading. So the code from this presentation is all on GitHub. Swappy.co was the REST version of the Star Wars API. There's a couple of GraphQL sort of wrappers to the Star Wars API, but that's the one I was using for this. GraphQL.org is the official documentation for this. There's a good getting started guide on Ray Wenderlich. There's a few other bits and pieces, and then that GIF in the middle is from Spaced, and if you've not seen Spaced, I'd recommend watching Spaced. It's great. That's sort of me, really. I've whipped through it way too quickly. Is there any questions?